Today in Algebra 2, Chapter 3, Section 1, we will learn to solve linear systems by graphing. Let's talk about what a linear system is. Okay, a linear system will be two equations that can be written in standard form. Okay, standard form ax plus by equals c. And you must have two of them. Okay, now linear, remember that linear is going to make a line. So we will have one equation that makes a line, and the second equation will make another line. The solution to the system is going to be the ordered pair where they intersect. And an ordered pair is represented by x and y, which are the coordinates on the coordinate plane. Okay, so a solution is the ordered pair where those two lines cross. When graphing a linear system, one of three things will happen. The first thing that can happen is that you can graph the two lines and you can have one point of intersection. Okay, in this case, your solution would occur at 2, 2, because that is where the two lines intersect. Okay, that is one solution. When you have that one solution where the two lines intersect, it is called a consistent solution, and it is independent. Okay, that is really important. Consistent and independent if the two lines cross and you have a solution. The second thing that can happen is that the line can be the same line, and you can get one line, and then right over the top of it will be the second line. When this is the case, your solution, you have an infinite number of solutions. When you have infinite solutions, it is also consistent, but then it's also dependent. Okay, the solution to this is we'll have infinite solutions, and it's consistent, but it is dependent. Where when you have one solution, it is consistent, but independent. The third thing that can happen is you can graph the lines, and they won't ever intersect. They will be parallel to each other. If they never intersect, then they are said to have no solution. If they have no solution, that means that they are parallel. They will have the same slope, but they have different y-intercepts. And that is said to be inconsistent. All right, let's go back over that. Okay, if the two lines cross, you will have an ordered pair as a solution, and that is consistent, independent. If the lines lie on top of each other, like they do in the second graph, you will have an infinite number of solutions, and that is also consistent, but it is dependent. The third thing that can happen is that the lines can be parallel, which means that they have the same slope but different y-intercepts. You have no solution because they never cross, and that would be inconsistent. Let's look at an example where we will have one solution. If you have a system whose first equation is 4x plus y equals 8, and whose second equation is 2x minus 3y equals 18, we need to graph those. Okay, when we graph those, before we can do that, we need to put them in y equals mx plus b. So our first equation, we need to take the 4x and move it to the other side. So that means we need to subtract the 4x. So it will leave us with y equals negative 4x plus 8. When we graph that, our y-intercept is occurring at 8. And our slope is negative 4, so we can go down 4 and then to the right 1, down 4 and to the right 1, and then we can draw our line between those points. When we look at our second equation, we need to solve for y, so we're going to move the 2x over, and that will leave us negative 3y equals negative 2x plus 18. Now we need to divide both sides by negative 3. So when we do that, we will have y equals negative 2 divided by negative 3. That's going to turn positive. That's 2/3 x. 18 divided by negative 3 is negative 6. So here, our y-intercept is occurring at negative 6. Our slope is 2/3, which means we're going to rise 2 and run 3. Again, we can rise 2 and run 3. And then we will draw our line there. So now we need to find the point of intersection. We can see that our point of intersection is occurring at 3, negative 4. You can check your solution by plugging that ordered pair, the x value of 3 and the y value of negative 4, back into the original equation to make sure that it makes a true statement. So if we take the 3 and we put it in for x, that would be 4 times 3 plus negative 4. Does that equal 8? Okay, that's in our first equation. So that would give us 12 minus 4 is 8, and that equals 8. So that's good. We did it. That is correct in that equation. Now we also need to put it into the second equation. Okay, so that would be 2 times 3 minus 3 times negative 4. Does that equal 18? 2 times 3 is 6. Negative 3 times negative 4 is positive 12. Does that equal 18? Yes, it does. And so it worked in both equations, so we did get the correct solution. The second thing that we said could happen was that the lines could lie on top of each other and we could have an infinite number of solutions. So let's see what that looks like. If we look at our first equation here, 4x plus 2y equals 4, and we want to graph that, we need to put that in y equals mx plus b. So the first thing that we do is take our 4x and move it to the right side. That leaves us with 2y equals negative 4x plus 4. Then we would divide everything by 2, and we would get y equals negative 2x plus 2. When we graph that, we have a y-intercept at 2. The slope is negative 2, so we're going to go down 2 and right 1, down 2 and right 1, or we could have gone up 2 and back 1. Okay, and then you have that line. Our second equation, 2x plus y equals 2. We need to solve for y, put it in y equals mx plus b. So we're going to move our 2x over, so it will be negative when we move it over, and we will get that y equals negative 2x plus 2. Okay, so our y-intercept is at 2. Our slope is negative 2, down 2 over 1, and then you'll see that it is exactly the same line. So it lies on top of each other. So every ordered pair that is a solution for one line is also a solution for the other line. Okay, that gives us an infinite number of solutions. The third thing that we said could happen is that the lines could be parallel and never cross. Let's take a look at what that would look like. Okay, in our first equation, 2x plus y equals 4. We're going to put that in y equals mx plus b, so we move the 2x over, and we're going to have y equals negative 2x plus 4. So we're going to go to our y-axis, and our y-intercept is occurring at 4, and our slope is negative 2, so we're going to go down 2 and to the right 1. Or we could have gone up 2 and to the left 1. Do a couple of those. Okay, so now we have a line falling to the right. The second equation, 2x plus y equals negative 3. Again, we are solving for y so that we can put the equation in y equals mx plus b. We have y equals negative 2x minus 3. The y-intercept is negative 3. The slope is negative 2, so we're down 2 and over 1. Down 2 and over 1. Or we could go up 2 and back 1. Same thing. And you will see when you do this that the lines are parallel. When lines are parallel, they're never going to cross. Okay, therefore we're going to have no solution. Okay, I want you to notice this. The slopes are the same. Okay, they both have a slope of negative 2. but they have different y-intercepts. One has a y-intercept at positive 4, and one has a y-intercept at negative 3. So if the y-intercepts are different but the slopes are the same, okay, then they are never going to cross and they will have no solution. So what I'm looking for from this unit from the video quiz, what did you get out of this? You should know that a system of equations is two equations that have our x and our y. They are linear, which are making a line. One of three things can happen. The two lines can cross, and the ordered pair where they cross is the solution. And that solution is called consistent independent. The second thing that can happen is that the line can lie on top of each other. And when that happens, you have an infinite number of solutions. And when you have an infinite number of solutions, okay, that is consistent dependent. The third thing that can happen is that the lines can be parallel and there will be no solution. And if that is the case, where there is no solution, then that is called inconsistent. Y'all have a good day.